You know, I was thinking about the continual glucose monitors the other day and seeing these things, people wearing them.
Yep.
And I got to thinking, man, is that needle sticking into somebody's vein or where is that? It seems like an awkward kind of way to monitor things.
That's a good question because you can't have something sticking into your vein all the time and measuring in your blood. So
awful.
actually, that sensor is measuring into your interstitial fluid. So
that makes sense.
let me explain the difference.
Please.
So blood is the red liquid that just flows to your veins, and it's generally inside your veins and doesn't just flow freely in your body. It's just still in the tubes. Whereas interstitial fluid is a fluid that's actually surrounding your cells. So that's kind of outside of your veins, and much more easily accessible for us. And these continuous monitors, glucose monitors, lactate monitors, they're measuring that because you can just stick a tube into your vein continuously. But so if you want to measure continuously, you have to measure in your interstitial fluid.
Makes sense.
And the consideration there is that actually you're lagging behind 5 to 10 minutes on the values that are in the levels that are in blood. So in blood, you'll see an immediate spike in glucose, for example, and only 5 to 10 minutes later, you can measure that in the interstitial fluid.
Sure, but I guess the trade-off there is that it's been a couple of years since I had blood work done, so a couple of years versus 5 to 10 minutes. I don't think
absolutely.
It's
I mean, in the scheme of things, that's nothing. But it's just maybe a consideration when you are modifying your behavior or you eat something, then you have to wait a little bit longer for that to be measured in your interstitial fluid. The other consideration in interstitial fluid is that larger proteins find it really hard to transfer out of the blood in the interstitial fluid. So you can't really measure larger proteins or things like red blood cells, hormones that are bound to large proteins or large proteins in general. So what you can use it for are things like small molecules like glucose, lactate, histamine, creatine, urea. So all these things that you can measure in this interstitial fluid and also continuously measure in the interstitial fluid.
Very nice.
Yeah.
Very cool. Yeah, well, thanks for clarifying that for me. I know when I was watching that, people walking around those things like, oh, that can't be.
Yeah, and actually on the bottom of that is generally a little micro needle type patch or a little tube sticking in the interstitial fluid. So you see that kind of passively through diffusion, the molecules will get to that sensor and then we can measure it.
Amazing.
Yeah.
Very cool.
Great.
All right, well, thanks for that, Joris.
You have a great day.
Have a great day.